In this video, we'll talk about finding intercepts of a graph, given a graph, and also just given the equation, how to find those algebraically. So first off, what are x-intercepts? So x-intercepts are the points where the graph crosses the x-axis. So these points are going to be somewhere on the x-axis, that is this horizontal axis, and we are just going to identify the ordered pair of those points, and keeping in mind that a point on the x-axis is always some number and then 0. So the y-coordinate is always 0 for an x-intercept. The y-intercepts are points where a graph crosses the y-axis. So, for instance, if I had a y-intercept of 0, 4, right, at the point 4 on the y-axis, it would be of the form 0 and some number. So that is the x-coordinate is equal to 0 for y-intercept. I have an example. We want to find the x and y intercepts of each graph. In example A, I have a line that goes through -4 on the y-axis and 2 on the x-axis. And so those are going to be the key points of this graph. My x-intercept is the ordered pair 2, 0. And my y-intercept is the ordered pair 0, -4. Then I have a graph of a circle that crosses the x and y-axis in 2 points, crosses the x-axis at 3 and -3, and also the y-axis at 3 and -3. To find my x-intercepts, I'm just going to identify these points on the x-axis, which are 3, 0 and -3, 0. And then my y-intercepts are 0, 3 and 0, -3. Now I have a parabola that actually has this vertex at the point 1, 1, and it goes through 2 on the y-axis and also the point 2, 2, just to get a perspective of this. So notice that the graph crosses the x-axis at none of those points on the graph. We say that there is no x-intercept. The y-intercept is this ordered pair 0, 2. In part D, I have this half parabola that opens to the right from this point of 3 on the x-axis. So notice that there is no point on the graph where it crosses the y-axis, so for the y-intercept there is none. And my x-intercept is this point 3, 0. So when we have the graph, it's pretty easy to identify what the intercepts are. Now we'll talk about finding the intercepts algebraically. And so if we're given the equation, in this case like 3x plus 9y equals 18, to find the x-intercept, we just need to recall that at every x-intercept, right, every point on the x-axis, the y-coordinate is 0. Algebraically, that means that we're going to let y equal 0 in that equation and then solve for x. So we would have 3x plus 9 times 0 equals 18, or 3x equals 18, or x is equal to 6. Therefore, the x-intercept is the point 6, 0. To find the y-intercept, we need to recall that every point on the y-axis has an x-coordinate of 0, so we will let x equal 0, and then solve for y. We would get 3 times 0 plus 9y equals 18, or 9y equals 18. Dividing by 9, we get y is equal to 2, which corresponds to the point 0, 2. And then for this particular equation, if we know those 2 points, 6, 0, and 0, 2, we could actually get the graph of that because this is a linear equation in 2 variables. Again, we'll talk about this in more detail later, but knowing 2 points is sufficient. We could draw the line through those 2 points to get the graph of the equation. So let's apply those skills to find the x and y intercepts of each equation, if they exist. We have the equation negative 2x plus 4y equals 16. So to find the x-intercept, we let y equal 0 and solve for x. We would get then negative 2x plus 4 times 0 equals 16. So this is negative 2x equals 16, and dividing by negative 2, we would get x to be negative 8, or the x-intercept then is negative 8, 0. For the y-intercept, let x equal 0 and solve for y. We would get negative 2 times 0 plus 4y equals 16, or 4y equals 16. So dividing by 4 gives us y is equal to 4. Therefore, the y-intercept is the ordered pair 0, 4. Part B, we have y equals x squared minus 4. So the x-intercept, again, we let y equal 0 and solve for x. We would get 0 equals x squared minus 4. And now we will apply what we've learned in earlier sections. This is a quadratic equation. I'm going to write it as x squared minus 4 equals 0. We can apply the square root property by adding 4 to get x squared equals 4. Therefore, x is equal to plus or minus the square root of 4, or plus or minus 2. Therefore, this equation has two x-intercepts. They are 2, 0, and negative 2, 0. The y-intercept, we will replace x with 0 and solve for y. So we get y is equal to 0 squared minus 4, but that's just 0 minus 4, negative 4. So the y-intercept is the ordered pair 0, negative 4. Part C, we have y is equal to the square root of x plus 3 to find the x-intercept. Let y equal 0. This would give us the equation square root of x plus 3 equals 0. Recall we solved a radical equation earlier. We need to square each side to remove the square root. This gives us then x plus 3 equals 0. Subtracting 3, we get x is equal to negative 3. If we plug that into the original equation, the square root of negative 3 plus 3 is the square root of 0, which is 0, so it checks. So our x-intercept is the ordered pair negative 3, 0. The y-intercept is found by replacing x with 0. Therefore, we would get y equals the square root of 0 plus 3, which is the square root of 3. So the precise y-intercept is 0 square root of 3. If we wanted to approximate it, it would be 0, 1.7 if we round to 1 decimal place. Part D is y is equal to 1 divided by x minus 3 plus 5. So the x-intercept, we let y equal 0. And we will get 1 divided by x minus 3 plus 5 equals 0, which is a rational equation that we need to solve by multiplying through by the LCD. The LCD is this x minus 3. If I multiply each term by the x minus 3, one over x minus 3 times x minus 3 is just simply 1, plus 5 times x minus 3 is 5x minus 15 after we distribute. And then 0 times x minus 3 is just 0. combining like terms, on the left we get 5x minus 14 equals 0. So 5x is equal to 14, or x is equal to 14 fifths. So the x-intercept is the ordered pair 14 fifths, 0. And then the y-intercept, we replace x with 0. And this gives us y is equal to 1 divided by 0 minus 3, then plus 5, which is negative 1/3 plus 5. And if we want to write that as a fraction, we need to get a common denominator of 3. So this is really negative 1/3 plus 15/3. Do you remember that 1 goes into 3 3 times? 3 times 5 is 15. Then we have the same denominator, so we can add the numerators to get 14/3. So therefore, the y-intercept is the ordered pair 0, 14/3. And in the last example, we have y is equal to x squared minus 4x plus 3. This is an equation we actually graphed by plotting points earlier. But to find the intercepts, for the x-intercept, we let y equal 0. So we would set x squared minus 4x plus 3 equal to 0. This is a quadratic equation. Let's see if it factors. To factor, I need to find the factors of 3 whose sum is negative 4. And those do exist, right? A minus 3 and minus 1. Therefore, x minus 3 is equal to 0, or x minus 1 is equal to 0. We get then x is equal to 3, or x is equal to 1. So there are two x-intercepts, 3, 0, and 1, 0. And then the y-intercept is found by letting x equal 0. So y would be equal to 0 squared minus 4 times 0 plus 3, which is just 0 plus 3, or 3. Therefore, the y-intercept is the ordered pair 0, 3.